Hello everyone, we're starting a new chapter. It's on polynomials and rational functions. Your first section is the quadratic functions. We're going to be looking at how to graph, x-intercepts, y-intercepts, vertexes, those different types of things and how to solve. So I hope you're ready. Make sure you have your notes out and let's go. Okay, so we have to recognize a parabola. So I'm hoping you're remembering that that's an x squared. We're going to determine if it is a min or a max. So remember that has to do. So if you have your x squared is positive. So if you had a positive, let's try that again. So if you have a positive x squared, that means this x squared, wow, this is being really weird today, opens up. So then you have a min. And if you have a negative value in front of your x squared, then it opens down, and then you have a max. That's all that is. Okay, and we're going to solve problems involving quadratic functions with min or max values. So where is our turning point is what we're looking at. So let's go through here. Your first version of a parabola is called vertex form. So it's already solved for you. And there's nothing too elaborate about this. You remember your h and your k are your vertex. It's the opposite of the h that's in the problem and k as is. So your vertex is a positive h and the k. Your line of symmetry is the h value. So it's x equals h because it's a line. Opens up. So remember, if you have a positive a, it opens up. If you have a negative a, it opens down. To find the x-intercepts, we let y equal 0. And to find the y-intercepts, we let x equal 0. So let's go down and see if we can get this thing graphed. So the first thing we're going to do, and this is the easiest form, and I won't give you very many of these. Generally, I want you to create this form, but we will start here anyway so you remember what you're looking at. So first we look here and here for our h and our k. So it's opposite of the -1. So it's 1, 4 is our vertex. So we go over to 1, 4, and we graph our vertex, or our turning point of our parabola. Okay, next our line of symmetry is just the x equals 1. This is not technically part, that's an x, of your graph, but it helps us so we know where our symmetry goes. So we go down here like so, and we label that x equals 1, and it's always a dashed line because it's not part of the parabola. I know it is a negative, so technically a equals a -1 here, which means it opens down, which indicates that I have a max. X-intercepts are where it crosses the x-axis. In order to find them, we let the y equal 0. Remember, your f of x is 0, so we just solve here. We say 0, and we write in our equation. Now we're solving for x. We already have a single x, so we don't want to make this more difficult. So the first thing we do is we subtract the 4 over. So you're getting rid of this guy. All right, now remember, in order to use our square root function where we can square root this, we have to have this by itself. So we can divide by a -1. That's really what that is. I'm out of room here. So now we have 4 equals x minus 1 squared. To remove the square, we take the square root of both sides. So now we have plus 2 equals x minus 1, and we also have minus 2 equals x minus 1. Solve for your x, you're adding your 1. And we know that x equals 3 and x equals -1. So on our graph, we go to 3. There's my other point and -1. So now my two x-intercepts, these are always written as points, are 3, 0, -1, 0. Now we want to find the y-intercept because I'm actually going to expect you to graph 5 points on these. And the y-intercept is where you let the x equal 0. So now we have y equals, so we're up to this equation, remember f of x is y, -1, 0 for the x, plus 4. So now we have -1 squared is 1. 1 times -1 is -1, plus 4. So we have my y-intercept is 3. That is written as 0, 3, because now the y has the value. So we go to 3. Now we mirror that over my axis of symmetry. So I'm 1 away from my axis of symmetry. So I go 1 on the other direction across the axis of symmetry. Now I have my 5 points, and we sketch in our parabola. Isn't that pretty? All right, your turn. So pause and try yours. Okay, first thing you should have said is my vertex. I hope you remember it was opposite of this guy is -3, -4. So we go to -3, -4, and we put our vertex. We know our axis of symmetry is the x value, so that's x equals -3. So here is my axis of symmetry, or my mirror line. Okay, next we have to find our x-intercepts. And we do that by letting y equal 0. So we're going to add the 4. And then you divide it by the 2. Now you took the square root of both sides. And this is ugly this time, which is fine. Let's go to 1 decimal place when we do this. So we'll say 1.7 plus, and then we also have to have the -1.7. Remember, you guys get 2 values here. So now you're going to subtract the 3. From both sides. So now you've got a probably -1.3 and a -4.7. So let's graph those. -1.3 is roughly here. -4.7 is roughly here. Next, we have to find the y-intercept. So I'm just going to do that in a different color since I am short on room, so you can follow me along, okay? So let's do that one in blue. So now to the y-intercept, let's go over here. We'll say the y-intercept is when you let x equal 0. So we'll say y equals, so we're looking for the y-intercept right now. Oh, I forgot to write these in point values so you don't get in trouble. -1.7 comma 0, I'm sorry, that was 1.3. -1.3 comma 0, -4.7 comma 0, my first two. Y-intercept, you let x equal 0, so now we got 2 times 0 plus 3 squared minus 4. So 9 times 2 is 18 minus 4, which is 14. So my y-intercept is 0, 14. I know that's off the graph, so we're just going to put one up here. I'm 3 away this direction, so now I'm going to go 3 away from my axis of symmetry. But my other one, I have my 5 points to sketch in. Whoops, I think I missed my dots. My parabola. I hope you did well. Okay, let's do the next one. I want to look at this and determine if a function has a min or a max. I want to find the vertex of the parabola in general form. Now, I'm hoping you remember this, but if you do not, the value of the vertex, the x value is the opposite of the a over the b, 2b, opposite of b over 2a, and then you take that answer and you plug it into the original to find the y value. To determine if it opens up or down, you look at the a value, just the number in front. So remember, if it's positive, it opens up. If it's negative, it opens down. Remember, if it is a positive value, it is a min. So if it's a positive, it is a min. And if it's a negative, it is a max. Axis of symmetry is always whatever you found up here. So it will be x equals the opposite of b over the 2a. X-intercepts, you can do factoring or the quadratic formula from the original. Y-intercepts, you let x equal 0. So here you do y equals 0. Nothing has changed. X equals 0. Just a little few different steps that we do in between. So I look at this and I would know if my parabola opens up or down. So I notice that I have a negative x squared. That means this parabola opens down. So it's going in this direction. I know it's going to be a max because it's opening down. And now I got to find the vertex. So we go x equals the opposite of b, so opposite of 4, so -4, all over 2 times a, which is -1. So you have -4 over -2, which is a +2. Okay, to finish finding the vertex, we take the 2 and plug it back into here. So we got to find the y value. So it's negative 2 squared plus 4 times 2 plus 1. So now remember only the 2 is squared, not the negative. So this is negative 4 plus 8 plus 1. And we get 5. So our vertex is 2, 5. So let's go graph this thing. We go to 2, 5, and this is my vertex. I should have put in my axis of symmetry already. I forgot to graph him on you, which was x equals 2. Now we're on to the x-intercepts. So I got an x-intercepts, I let y equals 0. So 0 equals negative x squared plus 4x plus 1. Well, there's no way factors of 1 are going to add 4, so we're probably going to use the quadratic formula here. I need to get my calculator out here. I'm going to pause while I find mine. Okay, I found my calculator. I hope you did it while you were looking. So we did the opposite of b, which is negative 4 plus or minus b squared minus 4ac all over 2a. When you type those in, you got a negative 0.23 and a positive 4.23. So our 2 points are over here, negative 0.23 comma 0 and 4.23 comma 0. So we graph those on our graph, negative 0.23, 4.23. Next thing we have to find is the y-intercept. Well, in this form, when you let x equal 0, you get y equals 0 squared plus 4 times 0 plus 1. The x values will always cancel out, so your y is just the c. You don't have to show any work. So now our point is 0, 1. So we go to 0, 1, and that is my y-intercept. So I also must go 2 over from the other side and graph my my other intercept, my mirror, and we draw in our parabola. All right, it is now your turn. So pause and try yours, and let's see how you do. I don't think my thing is pausing. All right, that's all right. We'll just do it together. So your first step is you look at opens up because you have a equals 2. Means it opens up, which means you have a min. Next thing you had to find was your x value. So x is equal to the opposite of b over 2a. So you got a negative 5/4. So you got the x value, so you go to negative 1 1/4. And we're going to draw in our axis of symmetry. Next you plug in your negative 5/4. Now this is just acting weird today. Okay, I figured out how to pause it, so I hope you did well. So first thing you did is you plugged in, you find your axis, your A2, opening up. We did opposite of B, negative 5 over 2A, 2 times 2, so you got negative 5/4, so that is your axis of symmetry. I plugged the negative 5/4 into my original, so here and here, and I got a negative 2.1 or 10.125. So now my vertex is negative 1.525, negative 10.125, and we put our vertex in. X-intercept, this time I chose to factor, because it looked like it would probably work fairly well. So you multiply, you got a negative 14x squared. Factors of negative 14 that equal the positive 5 are the 7 and the 2. Make sure this is plus a negative. Grouped, factored out, and we have negative 7/2 and 1. So our 2 points are negative 3.5, 0, and 1, 0. So we graph those, negative 3.5 and 1. Y-intercept is just the c value again, so it's negative 7. So that's 0, negative 7. We graph it and mirror across the axis of symmetry and drew in your parabola. I hope you did well. Okay, next one. I would like you to try this one also. Does the following function have a min and max? Where does it occur? What is the value? So I'm not asking you to graph this time. So pause and go. So does it have a min or max? First thing you should have said, you would have said a equals 4, which means this parabola opens up, which means it has a min. First question, where does it occur? This is asking you, what is the vertex? Is what it's asking. So we're going to do x equals the opposite of b. So positive 16 all over 2a, which is 8, which gives you 2. We must plug that in to find our y value. So y equals 4 times 2 squared minus 16 times 2 plus 1,000. And you would have got 984. So my point is 2 comma 984. So where does it occur and what is its value? So it occurs at 2 with a value of 984. We don't know what this means because it's not a story problem yet, but that is where we're headed. So we'll put this with words in a little bit. Okay, here's a story problem. Pause and give it a shot. Let's see if you can figure this out. Gave you a couple hints. All right, I hope you drew your problem. So here's my rectangle. I have x's and y's for my length and my width. I know from my reading that the perimeter is 120. I want to find the max area. And how do we do that given perimeter? Well, the two formulas you know is area is equal to length times width. And you know that perimeter is equal to twice the length plus the width. Whoops. I should probably stick with the same variables. Okay, in mine, I let the x equal the length and y equals the width. Okay, I got perimeters 120. It's the only number I'm given. So over here, I'm going to plug that in. I know 120 is equal to 2 times, since I used x and y, it'd be x plus y. Well, if I divide by 2, I know 60 is equal to x plus y. All right, I also know my area is x times y. I want to maximize area, but I can't do that with two variables. So I need to use this equation in here to get to one variable. So I need to solve for either one of these. It doesn't matter which one. So let's just use x. How's that? So 60 minus y equals x. Now I'm going to use substitution and plug that in here. So now instead of x, I'm going to plug in 60 minus y, and I'm going to multiply that by y. Well, if that's the case, my area is equal to 60y minus y squared. Let's rewrite this in the right order. So negative y squared plus 60y. I chose y on purpose so you could realize it doesn't always have to be x you're solving for. So now when I'm looking at this, I want to find, this is a parabola, right? Because it's y squared. Doesn't matter if it's y squared or x squared because it's really length and width, correct? It's not x and y like you were thinking. So I have y squared, so I know my vertex is equal to the opposite of b over 2a. Well, I know this is b and this is a, so I have negative 60 all over 2 times negative 1, which is 30. Okay, so this occurs when y is 30. Now I'm going to plug that in to figure out what my width is, or my x. So now I'm going to find my y value of my vertex, or my x value of my vertex. We're going to find the area. So we're going to say that 30 is y. So I'm going to do minus 30 squared plus 60 times 30. Type that into your calculator and you get 900. So my max area is equal to 900 square feet, correct? It occurs when y, or my length, is 30. But I know that those together adds up to equal 60. So I can say, I'm going to use this equation, that 60 is equal to x plus 30. Subtract the 30 and x is also equal to 30. So my dimensions are my length times width is a 30 by 30. So it's actually a square. All right, I hope you did well on that. Good luck on your homework. Make sure you text me questions or post on your discussion board.